And so the agenda for today is I'm going to give just a very brief introduction to PowerExchange batch architecture, just as to put some of this whole PowerExchange change data capture in some of our context. And then we're going through a overview of the PowerExchange change data capture, and then some ideas about some specific features of change data capture that make using change data capture quite a bit different from actually accessing a database directly. And so these are some very important concepts and I guess that once again, just to say is that this presentation is heavy on concepts and not very heavy on specifics. So there won't be very many specifics, and so we'll have to leave any of the specifics about some of these topics either up to reading the documentation or maybe to some future presentations. So that once again, we are going to be heavy on concepts. So let's start with the PowerExchange batch architecture, just as a brief introduction. The purpose of PowerExchange batch is to provide the ability of PowerCenter session, and issue SQL, to use the SQL issued by PowerCenter sessions to directly access the databases primarily on the mainframe, and the legacy databases on the mainframe, and the databases elsewhere. And I guess from an architectural perspective, the first thing that you'll notice about the architecture with PowerExchange is that when a PowerCenter session connects to a database, it does not connect directly to the database. It connects first to what we call the PowerExchange listener. And the listener is a process that runs on the same platform as the source database and connects, and then it is the listener that connects directly to the data source. So there is a component of PowerExchange that runs on the Informatica PowerCenter platform on the integration service, and that component communicates with PowerCenter and then also communicates via TCP/IP with the PowerExchange listener. And then the listener spawns a separate process that then connects to the database that is being accessed, so whether that's either on the mainframe or on Unix, Linux, or on the AS400, which are the sources. So that's this batch architecture. In the batch architecture, it is now the listener accessing on behalf of the workflow of the session on the this listener running on the platform of the data source and accessing the data source. And these, in fact, the change data capture architecture is very similar in that, but with it, I guess the first thing I want to talk about is that rather than accessing a database with the listener, you're going to be accessing the changes, and the object that we use to define those changes is we first have to use the PowerExchange GUI or navigator to create a capture registration. So the capture registration is now tells PowerExchange which tables or files are we're going to do change data capture for. And then it also at the same time creates an extract map, and the extract map is now the object that will be used to extract those changes. So you will be actually accessing through the listener the extract map rather than the table itself. And so when you import, import the object to create a source qualifier in PowerCenter, you will actually be importing the extract map rather than the source database. So how is this all done? So that the whole idea of change data capture is to provide the ability for a PowerCenter session to capture, we're going to capture the data and then deliver it as many times as needed to one or more, multiple PowerCenter sessions. So when we look at the three platforms that are supported, which are ZOS, then i5OS, which is AS400, and then Linux, Unix, and Windows, those platforms, there's a slight difference in the architecture for PowerExchange CDC. on the mainframe, which is on the left part, ZOS, which is the left part of this presentation, you'll see that we have the 6 sources, database sources that we do change data capture from, which are AdaBase, Datacom, DB2, ZOS, IDMS, IMS, and VSAM. So those are the database or file sources from which PowerExchange supports change data capture. And there will be a collector or an ECCR running on that platform on ZOS that will interface with the database logs from each of those tenants. So these are like, it was an, these are sort of the recovery logs that are used, and it will then interface with those, read the changed records that were on those recovery logs, and then write them to a separate process that runs on ZOS, which is the PowerExchange logger. That logger now becomes a change stream that will be read by the PowerExchange listener when a PowerCenter session connects. It issues the SQL and now can read this change stream from the logger. On the i5OS and LUW side, the logger is actually optional. It is typically recommended, but it is optional. So on the LUW side, the picture is very similar. Is that you have a collector that accesses the database logs. For example, with Oracle, it would be the redo logs. But accesses the logs, collects them, and then either writes them to a logger that runs on that platform, and then the listener can then connect to, will read these files that are created by the logger, which we call C&D files, or on the LUW platform or an i5OS, that listener can connect directly to the logger, to the collector, and read the change stream directly from the collector rather than going through the logger. We always recommend that people use the logger because it completely operationally separates the collection or capture process from the extraction process or the running of the workflows. So so what that allows you to do is have the collection process running continuously, and then you can stop and restart your extraction process, which would be the workflows, based upon either maintenance reasons or business reasons, or whatever the reasons are. But you can stop and start the extraction process without interfering with the continuous collection of the collection process. So what we're going to do now is look at a few specifics about how this collection process works on some of the more common data sources. First of all, just a quick overview of the sources that are supported by both batch and change data capture for PowerExchange. So on the CDC side, we have all the mainframe sources that we mentioned earlier, plus Oracle, SQL Server, and DB2 LUW and DB2 i5OS. So those are the CDC sources that we support. From a bulk source, we have all of those same sources plus sequential or flat files on the mainframe or on other platforms, and they're all supported as a source. And then we can have write back or as a target for all of those same except for Datacom and IDMS. PowerExchange does not support Datacom or IDMS as a write back mode. So that they are sort of very strange network databases that really don't lend themselves to being accessed through SQL. So now we're going to look at a little bit more about the specifics of the architecture of change data capture for the more common data sources. And in fact, the most common data source that we have, the most heavily used one on the mainframe, is DB2 on the mainframe. And as we've discussed before, the way this process works is that we have a collector, or as we call it, an ECCCR, that interfaces with a standard interface that IBM provides. It's called IFI 306. That the collector issues these IFI 306 calls, which in turn accesses the DB2 logs, and the collector then can parse those logs, reformat them, identify the ones that have been registered for change. So it's going to read the database logs for everything that's logged for DB2, but it's only going to capture the ones that have been, you've gone in and created a capture registration for with Navigator. So it will then reformat those records and write them to the PowerExchange logger that runs on the mainframe. Now that those records have been hardened to that change stream, they will now be available to be for the SQL that's being accessed, the selects that have been accessed, from PowerCenter session to access them, and the listener, which will connect to the listener. The listener will position itself on that change stream and return the change records to the PowerCenter session. So that's the same picture. You will see the same picture with really the only details being what happened in the lower left-hand corner of this session of the ECCR. So each database will have its own ECCR, and the technology that's used to collect those changes will be different. And so I'm going to go through a little bit of that technology for some of the other more common databases. One of the other heavily used databases on ZOS is IMS. And we actually have two techniques for capturing changes on IMS. We have one we call the log-based, which is just that where the collector runs, the collector process runs over there, and when a IMS archives one of its logs, that archived log is now available to the collector, and it will read that physical data set or file that is the archived log, parse it, identify the change records for those segments that have been registered for change data capture, and write them to the change stream, reformat it to the change stream. They're now available to the listener to be processed by workflows. The other option we have for IMS is what we call asynchronous, and the real difference here is the synchronous process really, the ECCR code or the collector process really runs as part of the IMS nucleus. So they actually participate in the IMS transaction. So as the transaction occurs, the ECCR has the change record available to it, and so it will capture it as that transaction occurs and write it to the logger where it's hardened, and now available. And so the big difference here is that the changes will be available on a much more timely basis, because they will be, and so you can run in really near real-time mode with the synchronous. With the log-based, you have to wait for the archive log to be created, so there will be a delay of however long in that environment it takes a active log to be filled up and archived. So there will be that delay before the changes are available. And depending on the business need, that may be more than sufficient. So both of these technologies are available for IMS. The other most common source on the mainframe is vSAM, and we support vSAM both in batch or CICS, where vSAM files can be accessed both in a batch mode or online mode or a CICS mode. And there are exits that are available from IBM that the collector or ECCR uses to capture the changes as they occur, very much similar to the synchronous IMS, and as they occur, and writes them to the logger where they're hardened. And so you now have this change stream on the logger that's now available to the listener and available to PowerCenter sessions. So the other sources on mainframe, database, and Datacom are similar, but I'm just not that they are used infrequently. And if you have additional questions offline, we can talk about those. Now let's go back to the other two major platforms that we support. One of them is the AS400. We have AS400, DB2 on AS400 is a very heavily used change data capture source, and architecturally it looks very similar to what we've seen before. Is we have the listener running on the AS400, and we have the change stream, and then we have the change data capture process, or the ECCR, which accesses the DB2 logs, which are called journals. But and in fact, we have several of the databases that are called journals, or and so in any case, it accesses the journals or logs through a standard interface that IBM provides on the AS400. So it uses that API to access the journals, parse them, and reformat them, and write them to the change stream. in a format that is very similar, to the ones that came from the mainframe sources. So when PowerCenter issues its SQL to read them, they're going to be in the same format as they were coming from the other sources, and it's all been standardized in that regard. Now, on the AS400, typically most customers don't write them to a logger. The logger is optional, but because in most shops the DB2 journals are available for a very extended period of long time, almost indefinitely, there's no reason to also relog the data, to harden the data separately onto logs. So most DB2 i5OS CDC customers don't use a logger, but just go to a virtual change stream where the ECCR connects directly to the listener and passes the changes on to PowerCenter. Okay. Let's see. Now on your Linux, Unix, and Windows sources, the logger is optional, but is more frequently used. We have two techniques for capturing the changes for Oracle. We have Oracle Log Miner, in which with Oracle Log Miner we actually use the Oracle Log Miner utility to read and pass the redo logs or the records off of the redo logs or archive logs onto the PowerExchange collector or ECCR, which then can pass them to the change stream, and that change stream once again can either be hardened and to the PowerExchange logger, or PWXCCL is the name of the PowerExchange of the LUW logger, and the LUW logger will then create its own PowerExchange logger files or CND files. And so now the listener when the PowerCenter session connects to a listener, it can optionally connect directly to the collector and read the changes from it, or it can more commonly connect to the logger and reads the CND files. And the real advantage of reading the CND files over directly is that it completely separates the extraction process or the PowerCenter process from the collection process, so that you can run, as we said before, run the collection process continuously and harden the changes to the CND files, and then they'll be available to the PowerCenter sessions, one or more PowerCenter sessions, without having any impact on the collection process. The other technique that we use for capturing from Oracle is Oracle Express, and Oracle, the picture looks very similar to it as we talked about, except with Oracle Express, Informatica has written its own log reader, which now reads the redo and archive logs directly rather than interfacing with the Oracle Log Miner. And the real advantage of it is that this process is much faster, so it can read a much higher volume of redo records than Log Miner could. And then the other two sources on LUW are SQL Server. And SQL Server is slightly different, the architecture for SQL Server, in that PowerExchange takes advantage of SQL Server replication. And SQL Server replication itself has its own log parser, which reads the SQL Server logs and writes the changes that have been registered for capture to the distribution database. And so there is a SQL Server table or set of tables called the distribution database that PowerExchange issues SQL selects to select the change records, and then writes them to the change stream, which could either be the CND logger files or the virtual change stream directly to the listener, and either option is available. And then with DB2, it's on LUW, DB2 LUW, once again, very similar. There is a standard log read API that's available from IBM that's used to give access to the DB2 logs where the PowerExchange collector can parse them, identify those changes to those tables that have been registered for change, and put them to the change stream, which can either be the CND files or directly to the listener. And PowerCenter sessions can then access those changes. So that is the high-level overview of change data capture. So now I'm going to talk about three things that really are unique to change data capture. And the first one is the unit of work cleanser. First of all, a definition of unit of work. A unit of work is a transaction. It's a source transaction that occurred on the source database. It's from the beginning of the transaction until that transaction is committed or aborted. And the records associated with that unit of work will be on the database log, whatever that database log. And then what the unit of work cleanser does, it does two things. First of all, it makes sure that only committed transactions are processed. So any aborted units of work or transactions that are on the database log are then ignored. And the second thing it does is it orders the units of work that are delivered to the PowerCenter session in the order in which they were committed on the source system. And I'm going to give you an example of how that works. So here's a little graphical example of how records are written to a database log and how they're processed by the unit of work cleanser. So this is just any database writing to a database log, and this could be Oracle, it could be DB2, it could be IMS, it can be any of the source databases for which we do change data capture. There will be something, it may be called something different, but it will be a begin transaction, and in this case there's going to be, in my little example, I have updates to the table A here, which is so these are now, what we're now seeing is the records as they exist on the database log. So this top row up here is the database log, is the pictorial representation of the database log. And then the next thing we see on this database log is a begin transaction for another transaction, because as transactions occur in a real world, they're overlapped, and so the records, the changes that are made and recorded on the database log they're written sequentially, but they're intermixed by transaction. So in this case, we have multiple records and then we have another begin transaction for a third transaction. So we now have three transactions that are simultaneously running and being logged to this database log. And so we have an update record, and then we have row 4 for, hey, that's transaction A. Now he made another update, and now we have an end transaction for the last transaction, and then we have an abort for the second transaction, transaction B, and then we have the end transaction for the input. So now we have this little snippet of the database log that let's go process with the ULW cleanser. So the ULW cleanser, and of course this, in a real world, this is going to be happening continuously for, but we look at this little snippet. So the ULW cleanser, the way it would process this little snippet of a database log is it will read the records sequentially and buffer them, and it will buffer them in memory, and buffer the memory as long as there's some PowerExchange parameters that define how large that memory is. It'll buffer them in memory, and if they won't fit in memory, it'll write them out to disk. But so typically they'll be buffered to memory. So as we see, as the ULW cleanser reads this database log, it buffers the transaction A, and then it sees the begin transaction for transaction B, so it creates a separate buffer for it, begins processing it, and we keep buffering. Once again, as the ULW cleanser, it's processing this database log, and it's passed nothing on downstream to PowerCenter yet. So all it's done is buffer this database log as it collects them from the collector, and is buffering them. But so it keeps reading these database logs, and now we see the end transaction for transaction C, and so it immediately is now written to the change stream. So you'll see that. So I guess the main concept that I'm trying to carry here is that records are written to the change stream in the order in which they were committed. So in this case, we see that the third transaction to begin in this little case is actually the first one that's written to the change stream because it was committed first. And of course, more importantly, is that transaction B, which is aborted, isn't written to the change stream at all. So the change stream will not have any information about transaction B. And then, of course, we get the end transaction for transaction A. So now it's written to the change stream. So now we see that the transaction that actually began first is actually on the change stream second because it was committed second. So the UOW cleanser is going to be processing the changes, all changes they occur, and reordering them in the order in which they're committed and passed on to the change stream. So let's look a little more different, a little more detail about what the change stream would look like. First of all, let's look at where that UOW cleanser actually occurs architecturally in slightly different places on the LUW platform versus the mainframe platform. On the LUW platform, it really happens as part of the collection process. So the collection process, so as part of the collection process, the UOW cleanser process is executed. So when the changes are written to the C&D files by the logger, or the PowerExchange CCCL or the LUW logger, they have already been through the UOW cleanser. So aborted transactions have been ignored, have been eliminated, and the records on the C&D files will be in the order in which they were committed on the source database. So when the listener accesses, on behalf of a PowerCenter session, accesses the C&D files, they will already have been through the UOW cleanser. On the mainframe, it's slightly different. On the mainframe, the collector writes the records directly from the database log, directly to the logger without going through the UOW cleanser, so that when the PowerCenter session connects to the listener to retrieve the records from the LUW logger, it then goes through that same UOW cleanser code and eliminates the aborted transactions and reorders them so that when they show up in the PowerCenter session, they have been through the UOW cleanser. So in both cases, the change stream that is seen by the PowerCenter session has been processed by the UOW cleanser. So let's look at that change, a little bit more detail about what that change stream would look like. So we now have, whatever the source database was on whichever the platforms we have. In my example, I'm looking at one where we have the logger that goes to, and a listener over there, and it goes through this change stream. And as we discussed before, we now have really three pieces of code that exist that processes. We have what we call PWX. So there's some interface code that runs on the integration service platform that interfaces with this change stream and processes this change stream and passes it on to the PowerCenter reader. And here's an example of a change stream, because I want to go through, give you a little bit more information about what the change stream would look like. First of all, you got to realize, of course, is that so each of these colors is a transaction. So what we have here is 5 UOWs or 5 transactions, and they're color coded, and they updates to 3 different tables: Table A, which is in red; Table B, which is in yellow; and Table C, which is in whatever that dark green is. And so the change stream now contains these units of work or transactions on the logger files or on the change stream. But another piece of information, there's some recovery information that is also stored on those same records as part of that transaction. So that recovery information, and we'll talk about a little bit later about how that recovery information is used. So in addition to the change record, there's some recovery information written to the PowerExchange log. And I guess the first thing you'll notice is that this change stream, and I think this is a good way to really think about it, is this is really just a sequential data set that contains the source transactions ordered in the order in which they were committed on the source database, and of course each individual insert, update, delete is in the order in which they actually occurred within that transaction. But so what we really process, so this change stream that's going to be processed by PowerCenter is a never-ending sequential data set. So even though these were transactions that overlapped and occurred on the source database, the way they're actually processed is by the PowerCenter session is a record at a time and a transaction at a time. And I guess just to make it clear, so what we would typically have in this case, we would have a PowerCenter session that has 5 source qualifiers, and it has 3 source qualifiers: a source qualifier for table A, a source qualifier for table B, and a source qualifier for table C. And as the changes occur in the PowerCenter session, arrive at the PowerCenter session through the PowerCenter reader, they will be routed to the appropriate source qualifier so that they can be processed. So that it will process the changes a change at a time, a transaction at a time, but the changes to each table will be processed separately for a different thread in the PowerCenter session. And then the commit will then be done at the end of that transaction with some separate options that we'll talk about here in just a minute. Okay. And then the third thing, in addition, that's really different about that CDC is recovery and restart. So just about some concepts. So the real objective of CDC recovery and restart is to deliver a change record to a PowerCenter session once and only once, so that a given change record can be processed exactly once and only once, and so that if the objective of this session is to keep a source table and a target table in sync, so the data integrity of making sure that every record was processed, you don't skip any, and that you process it only once is what recovery and restart's all about. And the way that is done is by saving this restart and recovery information that we talked about that's included in the change stream in a target table on the target database. So PowerCenter creates a set of recovery tables, and specifically the one that actually saves the information is a PMREC state table that's actually on the target database. And whenever a transaction is processed, that recovery information is written and committed to that PMREC state table at the same time as the data is committed to the target table. And when a session warm starts, it will read the information from the PMREC state table, pass that information on to the PowerExchange listener, will be passed on to there, where the session can now then restart right where it last left off. And so because that information is written, that restart information is written to the PMREC state table every time there's a commit, then anytime the session terminates, whether normally or abnormally, that restart information is saved in the target and then PMREC state on the target database, and now the session can reliably restart right exactly where it left off with no duplication of data. So now I have created once again, this little sample test case that I have, and I'm going to try to walk through a session log of the messages that you'll see in a PowerCenter session that are associated with this little simple change snippet of the change stream that we have here. And what we're going to see in this session, it's just a little Word document where I cut and pasted this session, so hopefully we'll be able to read it. We'll see the session initialization. We're going to see the messages in the session log where it read the PMREC state table to read the restart information, and it's going to position itself on the restart table and start reading on the change stream and start reading that table. And then we are going to commit each of the transactions and commit the restart information, and then we're going to terminate. So I guess just a couple of comments on why this is a simple case. First of all, in this case, the change stream is coming from a logger, and as we mentioned before, it might be a virtual change stream, but it conceptually is still the same. And then also there are quite a large number of options that control when the commits are done to the target. By default, the commit is done to the target for every source transaction. There are parameters which affect that. It can be multiple source, or it can be, you can take one source and do it more frequently than that. So there are quite a number of parameters that control when these sources are done, but we've taken the defaults in this case, and the options are pretty well documented in the PowerExchange manual. So okay. So now let's get out of this little. There we go. I guess just skip over to here right quick is that we talked a little about documentation. Is that there's a PowerExchange interfaces for PowerCenter manual, which has a lot of documentation about what all of the options in restart and recovery. So let me get out of this right here and get over to the, let's see, get over that. Sorry about that. Get to the, all right. Here is our session log that was in a Word document. So this is the session log that processed that that little snippet of that change stream that we saw before. So the first thing you're going to see in the session log are the initialization messages. And so we'll go on to that. And as we go down, we'll start seeing the very first messages that really are unique to PowerExchange CDC. And the first message we're going to see is a message that shows, and the red is just my annotations that say, is that, yes, in fact, this session has been enabled for recovery. So you'll see this message that says advanced GM recovery in effect. So now we know that recovery is enabled for this session. The next thing you're going to see is the PowerExchange connection information is going to be echoed. And one of the pieces of information is a restart token information. And the restart token is file name of the restart token is only used if it's to override restart on the change stream, rather than just a normal restart where it restarts from the right where it left off. So we'll see. So just for information, that information. So now let's go where it starts. So what I did was I'd already recorded, written some records to the logger, made some updates, and I brought up my workflow and started processing the changes that had been logged to the logger. So there were actually been that little change stream that we talked about, that we'd shown before, had been written to the PowerExchange logger, and now I brought up a workflow to process it. So I'm not processing these changes in real time. I've made the changes ahead of time, written them to the PowerExchange to PW logger, and now I'm processing them, bringing up a workflow to start processing them. So the first thing, first thing we see in the session log is that there was a warm start, and then we start seeing the initialization messages where each of the tables, where it's going to, first of all, it sees the session sees the message that says it found the recovery tables, that it actually existed. And the first thing it does is it says, oh my gosh, I did find the recovery information in the PMREC state table, and it echoes the recovery information in the PMREC state table. So this session restart information is, even though it looks just a bunch of numbers, is actually the position on the change stream that the PowerExchange listener will use to position itself on the change stream exactly where that left off. And if you see GMD storage in this message, that means that it actually read the information from the PMREC state table. Now it's gone through, and now the next messages indicate that the PowerExchange reader has actually read the first changes, the first transactions, the transactions off the change stream, And when it sees the end of that transaction, by default we had set that to flush, to do the commit and do the flush at the beginning of the source transaction. So we'll see this, that it took that first source transaction, echoed the restart information from that transaction, and committed it and put that transaction and passed it on to the rest of the, this is the reader, so it passed it now on to the rest of the session to be processed by any transformations existed, and eventually passed on to the writer to be written to the target database. In my case, there were no transformations, and the only thing that existed, so it would have passed it directly to the writer to be written. But because I had started this session up, and there were all of these records were queued on the table, this session was able to read these records faster than it was able to write them. So we actually saw it was able to, the reader was able to read them and issue the flushes faster than it was able to write them. So we actually see the read, and so so in the session log we see the first flush for the first transaction, and then we see the second flush. The first transaction has been read onto this point. It's just been read and read into DTM buffers, reader buffers, to be processed by that session, and then we read transaction 3. So at all this, so that so we see these messages as we go. Now the next thing is now we start seeing the source bits where now that they've been processed, they've been read. Now we finally see the first transaction is actually going to be written to the target database and committed, and you'll actually see, we saw that first transaction was an insert to table A, and we'll actually see here that there was a insert to table A, and there was an insert to table C. We'll see that, and an update to table C. So you'll see that the source-based, I guess, commit reflects the inserts, updates, and deletes that were processed by that transaction. And then at that point, that transaction was committed, and the restart information was printed. Now, I guess the point is that if I had stopped, because we still have 4 other transactions in the reader queue, and if this workflow had failed at this moment, right after it had committed this data to the target database, those other records that were in the reader queues would not have been committed. And so if this workflow had failed at this point, and you restarted the workflow and restarted the session, it would start reading right at the end of where this transaction 1 here had been committed, and so UOWs or transactions 2, 4 through 5 would have been reread on restart because they had not been processed by the writer at the time of the failure. But at the same regard, when I start processing transaction 2, in this case, and it is committed, if I had actually stopped the workflow at this point rather than actually abnormally aborted it, if I just stopped the workflow, what PowerCenter is going to try to do is it's going to try to read to process all of the transactions, all of the units of work that are in the reader buffers before it finishes. And so it would have flushed all of those before it goes. So that is, so in this case, we're going to go ahead and process all of the transactions. See the source-based commits for all of the source transactions, all 5 of them, and then I issue the stop to the message, to the session. It stopped and it terminated and wrote final termination messages to the session log. So we got to see all of that. So I guess at this point I'm going to try, I guess we will just open it up for some questions and see what we have, if there are any questions from anyone.
The leader has turned lecture off and your lines have been unmuted.
Hopefully I've put it back so I can hear any questions. Yes.
Yeah. Thank you so much. So everyone, the table is open for Q&A. If you want, you could post the questions on the chat, or could post the questions directly to Ron on the phone itself.
I guess I just want to go back and reinforce that if you have, the PowerExchange Interface for PowerCenter Guide is a really, really good source of information about how PowerExchange CDC and PowerCenter interact with each other.
I have a question.
Yes.
Okay. In your example, if you had one of the tables had multiple changes, let's say multiple updates onto the same record, how does PowerExchange handle that? Does it aggregate that, or does that up to the PowerCenter to aggregate?
Yeah, it would. Yeah, the PowerExchange. Each update is processed separately, and if there's any aggregation to be done, that has to be done by the application.
Okay.
There is one small exception to that, and once again, I have make sure I have covered the basic functionality of PowerExchange and CDC, and there's a lot of different options, but there's one small option is that we do have a condensed process that can optionally run on the mainframe that will actually aggregate the changes before they are passed through the PowerExchange listener and on the mainframe and sent on to PowerCenter. So there can be some aggregation done with the condensed process on the mainframe, and it is used. I mean, that's of course only of course those are only aggregating update changes that were made to the same key, right? And in real practice, the changes that are made to the same key in a given time frame is not that usual. I'm sure there are exceptions to that, but in most cases, the same key is only updated infrequently. Were there any other questions?
I have a question.
I guess just one point I didn't make earlier, but I want to just make is that because these changes are written from the recovery log on the source database, so that each record that is updated by a source transaction is processed as a separate record. But you've got to realize is if, for example, I had a update on a source database that updated 1,000 rows on the source database, each of those rows is written as a separate record on the source database log. And so when PowerExchange reads the source database log, it will read 1,000 records. So there'll be 1,000 records processed off the database log and passed on to PowerCenter. And that transaction would have been passed on to PowerCenter as 1,000 records rather than just one update that may have been done on the source database.
So it basically runs 1,000 SQLs on the target?
Yes.
For each transaction? For each
1,000
record?
1,000 SQLs. There's going to be a separate insert, update, and delete done for each. Let's just say you get an update of 1,000 records. There's going to be a separate update issued for each record that was updated on the source, even though there may have been one update done, one update SQL command issued on the source to update 1,000 records.
Okay.
We don't recreate the update SQL, right? Because first of all, the source and target may be entirely different schema, so that and those records could have been aggregated before they were actually written to the target. So in any case, I guess that yes. So there will be a separate update done for every record that was updated on the source.
You mentioned at one point that listener has to be running on the source environment.
On the source platform, yes.
On the source platform. Now, just wondering that, you know, as from the architecture point of view, can we have a centralized server that hosts a listener, and as long as it can read the log information from the source, would that suffice? You know, we have separate listeners running, but there is like one centralized server where all the listeners are set up for different source, and in some way we provide access to the log, read-only access to the listener. Would that be okay, or does listener have to be on the source platform?
It has to be on the source. By platform, I mean it's the same. You know, if the source is on the mainframe, then the listener has to be on the mainframe. You know, I mean you could have, you know, so the listener would have to be on the mainframe. If it's a mainframe source, if it's on a Unix source and you run Oracle on a Unix source, the listener has to be on Unix. But you know, if you have connectivity to those logs elsewhere. So the answer to your case, in general, with certain, we can't go into the details here. We don't have time to do that. But in general, it doesn't have to be. It doesn't have to. The listener does not have to reside on the same exact box as the source database. Okay?
I got it. Thank you.
Although there may be significant performance considerations if it does or does not.
Sure.
This is one of those it depends questions.
Ron, this is Patapi here. I have a question over chat here from Sajid. So earlier you mentioned about the update, insert, and delete in the change stream. What about if a source table gets truncated?
PowerExchange does not process DDL changes. Do you see any? If
PowerExchange doesn't handle DDL, and that's considered DDL by most database systems.
Yeah. You say when the table was deleted, is that what you said?
Truncated.
Oh, truncated. Oh, truncated. Oh, I'm sorry. Yeah, PowerExchange does not handle truncates. And of course, depending on the database, once again, you know, there are truncates that are logged and those that aren't. So once again, that's to some extent a depends question also.
In an Oracle database, truncates are not logged. That's why you use it in Oracle.
Right.
Right. Unless you are doing something like DataGuard with force logging, in which case the individual rows are logged, which violates the standard rule about truncate not logging in almost every DBMS, but only if you have force logging on. And even then, they're logged as a different kind of database log record, and LogMiner will correctly return those, but PowerExchange Express's log reader does not. So there is one case where you might get the delete through for the truncate, and that is if it's Oracle source, if you have force logging on, and if you are using PWX LogMiner CDC. If any of those answers is no, or for any other source database, the answer is all no.
We talked about the unit work and how if something fails, it will restart at whatever point it left off. But what if we realized, you know, we loaded this incorrectly, or we need to reload, we need to go back a day? How easy is it to roll back that unit of work? Is it just updating a table?
Well, okay. If you want to go back and restart your session to start reading on the change stream at a place other than exactly where it left off, if you want to go back and reprocess yesterday's data, is that what you're asking?
Mm-hmm. Or a few hours before.
Yeah, or 2 or 3 hours before. So once again, that restart information is, first of all, we saw in the session log, we saw that restart information was logged, right? So as it was being processed, and when the session terminates, it actually writes that restart information to a separate file, and what we call the restart token file. And so when the session warm starts, if something exists in the restart token file, it will override the contents of the recovery table or the PowerExchange table. So you have the ability to override restart information for a specific table over all of the tables in a session by putting some restart information in the restart token file.
Okay.
Now, whether it's easy or not to determine what to put there is perhaps debatable.
Is there a way
more than one session log, you can use entries from a previous session log to determine what to put in the restart token?
Right. Yeah. So right. And depending on the source, you know, some sources allow you to create, and this is once again the source database, right? Some source databases, Oracle is one specifically, where you can actually create a restart token based upon the SCN from the Oracle log. That ability to do that is not true for most source databases, but it is true for some of them. Oracle specifically.
How would one check if the source and target database are synced up at any point in time? You know, like say if you have 500 tables that you are trying to sync from source to target at distributed environments for distributed. Yeah. Is there a way where, you know, if a manager gets a call that, oh, is everything synced up, like something to quickly say that, oh yeah, you know, each of the records are synced up or not?
About the only option that Informatica provides is the DVO option, which will do, you know, will compare a source to a target, but there's nothing built into this whole CDC process that will do it.
That's almost kind of a nonsensical question for CDC, because CDC is continuously processing changes as they occur from the source. So there is no point in time where the source and the target will be exactly in sync unless you've stopped making changes on the source. There are ways to determine what your total throughput latency is.
Right. You mean the lag time, right? I mean, you can tell that it's lagging 10 minutes or so, but you know, in some way, if you want to make sure that, okay, you know, everything before 5 minutes is completely synced up. And what was the tool you said?
You'd have to stop changes on the source and run some kind of compare between the source and the target.
No, okay.
Right? I mean, odds are you're not extracting everything from your source database, and you may be doing things in terms of the way you have your transformation structured and the mapping that completely changes the target from the source. So that would be something you'd have to figure out how to do in terms of writing a compare. But PowerExchange doesn't lose data. So the question is really, what's your lag time? Because if your lag time is within 5 minutes in your example, then you know you're current. It's up 5 minutes ago, or whatever the lag time is. And we have recommendations for how to measure that, which is what we call heartbeat tables. And there's an H2L out there to tell you how to do that.
But if the question is to guarantee absolutely that every transaction was processed and written to the target, there's no external audit to do that.
Okay. And how anything specific related to, say, like if a network issue occurs between Power Center and target while this thing is going on, or between the source and Power Center, and it's down for a minute or for an hour, say, you know, so when it comes up, I believe based on the slides, it seems like it's going to check that table on the target side to determine up to what point it needs to start. Is that right?
Well, you actually have, and well, I don't know how, you know, we're running over time, so I don't know how long we want to do this, but there's actually two, you really mentioned two separate recovery issues. One of them is on the capture side, where the change capture side, where you're interfacing with the source, with the source database tables. And if there's an error there, so there is a similar restart and recovery associated with the change capture process, the ECCR. So if the database terminates, or if that change capture process terminates, when it restarts, it will restart on the database log where it last left off. So there's some internal PowerExchange positioning on the database log that it keeps track of. So if the capture process goes down for any reason, it will start reprocessing the database log where it left off, and then of course passing it on to the change stream that's now being processed by the PowerExchange session. Now the position on the change stream it's the position on the change stream that is what's in the PM-REC state table and for the processing by the PowerExchange session. But those two, recovery and restarts, are really totally independent.
Got it. Thank you.
But Ron, I think we are almost 5 minutes over time, but I have one final question here on the chat window. So would you want to take it up now, or do you want to respond back to them or an email? How do you want to?
I guess, let me just go, I'll tell you what, let me go ahead and give everybody on here my email, and they'll feel free to send me, and I will, do my best to answer in any of them, or at least point you in the right direction. And my Informatica email is rroot, R-R-O-O-T, @informatica.com.
Yeah, so I think another alternative would be once the recording of this webinar is available, we will be sending out an email to all the attendees. And you could also go and post your questions on the YouTube video itself, and we keep monitoring it on a regular basis. So we will have Ron on back to it as well. So that is another option as well. All right. Thanks a lot, Ron. Thanks for the wonderful presentation, and I would like to thank all the attendees as well for their time. So you can look forward for the next webinar registration details next week. We will be hosting that details on our support portal. So until next month, thank you, everyone. Have a good weekend.
Thank you. Thank you.
Okay.
The leader has disconnected. The conference will be terminated in 10 minutes.